All right. So we want to look at this one now and see if we can use the right-hand rule to help us. And you can see a bunch of things from looking at it. First of all, you can see that you have a straight line. It tells you in here that the field is uniform everywhere. And if you look at here, you have some positive charges, then you have no charge, and then you have some negative charges. So these will be all right hands. This will be no charge, and this will be, I would use my left hand. Okay. Now you can see that you have circular pathways, and they have different radii. So we need to figure out what's going on with the radius here in just a second. But first I want to talk about this line right here. This line right here, we're calling it pathway K. And so pathway K shoots straight through. The only one that shoots straight through is something that doesn't have a charge, so particle 6 must be pathway K. So let's go ahead and fix that. So particle 6 is going to be K. Because if there is no charge, there will be no radius. All right. So let's move on back up here, and let's look at this chart. The best way to look at this chart is to realize that there are different radius, different radii for different pathways. So I need to figure out what the radius would be given this information here. Well, I taught you that R was equal to mv over bq. R is proportional to mv over q because b is constant for everybody. They have the same value, so I'm just going to say it, not really caring about the b. I'm just going to look at the relationship between mv divided by q. So I go with this first one, 3m times 3v is 9. 9mv over 3q is going to give me a radius of 3r. The next one, m times v over 2, gives me a half r. This one here, 2 times 2 is 4. 4 over q gives me a radius of 4r. This one here, 2 times, let me make sure I'm doing this right, 2 times v, it gives me 2 over q gives me 2r. 1/2 m times 2v gives me just a plain mv over q, which gives me 1r. We said this had no r, so we're not going to worry about that. We already figured out that that was pathway K was particle 6, so we've already dealt with that one. 2 times v, 2v times m gives me 2mv over q, so that's going to be a 2r. This is going to be mv over 4, or a fourth of an r. This one's going to be mv over q, or 1r. This one's going to be 8mv over 2 is 4r. And this one's going to be 6mv over 2 is 3r. So now I look at my picture and say, okay, well, if this is a little tiny, tiny r, fourth r, I only see one that's a quarter r, so that tells me pathway D must be particle 8. Okay? So I dealt with this one, and I'm good to go. I'm going to just draw a line through that one because I already know what it's going to be. Took care of that one, and that one's easy because it was so small. But there's also another clue here. This tells me that this pathway right here is a negative charge. So that means that negative charge is going to move counterclockwise in my magnetic field, and I might find that helpful here in a minute when I'm doing some other things. This one would then probably be a negative charge. And I could look at this one as a negative charge. No, that's a positive charge. This is a counterclockwise, so probably a negative charge here, and so on. So I'm going to go ahead and just keep on working and just keep in mind this situation here. Best thing to do, though, is let's go ahead and look at the magnetic field and see if we can find out the direction of the magnetic field. So if it's a negative charge, which is what we said this one, let's look here. We said this one's definitely a negative charge. How did I know? Because it's a negative 4q and it has a radius of 1/4 r. So I'm going to take my left hand and I'm going to try to figure out the direction of the magnetic field. So I point my thumb straight up toward the top of the page of the paper, and my particle is experiencing a force that's pushing it inward like that. So my palm is going to face to the right, so my field must be into the page. So I'm going to put X's everywhere. So I'll know that that's into the page. And I can do this forever, but I'm not going to because I don't want to run out of time. All right, so we got that established. That makes our life a lot easier. Okay, so we know that this one has a radius of 2r, and it's a negative charge. Well, 2r with a negative charge tells me that this pathway here, which we just talked about, pathway J, must be for particle 7. Okay, so I've dealt with that one. All right. Again, I knew it was 2r and I knew it was negative, so my only negative 2r was this little rascal here. All right, let's go see if we can find a 1r and see if it winds up being a negative particle. Well, 1r is not that one. It looks like it's either this one or this one. Okay. Well, if I do my left-hand rule, because this, well, I'm going to do the left and the right and check it out. So if I do pathway B as being a negative particle, and I push my put my fingers pointing into the page, my particle going to the left, then my force would be causing it to go in a circle like that. So that would be my negatively charged particle. Let's see if that's true for, let me look at C also. So C only works if it's positive, so this one must be a negatively charged particle right there. And this one must be positive. So 1r that is negative has to be pathway B. So 1r, negative particle. So number 9 is taking pathway B. And let me go over again how I knew that. I said, okay, I'm going to try and see if this will work with my left hand. So I pointed my thumb to the right. My fingers are going into the plane of the page, and my palm is facing so that it would push the particle in that kind of a circular pathway. So pathway B had to be a negatively charged particle. I tried the same thing with pathway C, but there's no way that I can have the motion to the right and the field into the page and have it spiral like that or move in that direction. So I said, well, heck, I'm going to try my right hand. So I did, and my right hand makes the force be applied in that direction toward the center of the circle, which is exactly what I want. So I know that particle C has a radius of 1 and it's a positive charge, so 1 radius, positive charge right here, tells me that number 5, particle 5, is taking pathway C. Okay. And then I said, okay, I've dealt with the quarter and the 1s. Let's go figure out the 1/2. Well, I only have one particle that has a 1/2 r, so this one here tells me that it must be positive and it must be particle 2. So for the 1/2 r pathway, that is pathway, looks like E as an egg, and that's particle 2. All right, so I've done with my half, dealt with my half. 4r, 4r, 2r, 4r, and 3r. So I need to deal with my 2r. So here's a 2r. Here's also a 2r. But I've already said that this one is particle J. Pathway J is particle 7, so I need to go up here and deal with this one here. So there's my 2r. So I'm going to check, I'm going to make sure that I have it a positive charge, so I point my fingers into the page, my thumb points to the left, and my palm is facing so that it'll drive the particle in this type of circular pathway. So I know that I've figured out that that's a positively charged particle. So if the radius is 2r, that's pathway I, and that means that pathway I is taken by particle 4. And then, okay, I've dealt with that 2r. Haven't dealt with the 3r's yet, so let's look at the 3r's. So I have one here and here. So let's see what's what. My 3r's would be this one here and this one here. So I got to figure out what's going on with the right-hand rule and the left-hand rule. So I'm going to go with path A here. I'm going to point my thumb toward the top of the page. My index fingers are going to, or all of my fingers are going to be pointing into the page, and my force, my palm is going to be pointing to the right and to the left. My palm is pointing to the left, so that would make it move in a circular pathway like that. So since that was my right hand, I know that particle A is, or pathway A is for particle 1. So if my radius is 3, pathway A is the same thing as particle 1. So that means that this little rascal over here, path H, must be my negative. So I do the left-hand rule, and it works out that H is perfect. So for this one down here, the pathway is letter H, and that is particle 11. And then all I have left are my 4r's. My 4r here and 4r there. So here's a 4r. Well, I already know A is positive and it moves in that direction, so G must be positive. So this 4R must be pathway G, which is particle 3. And then I can go to this 4R here, which is this one here. I've already assessed that H is negative, so pathway F must be for a negative particle. So that's F, and that is pathway 10. So now I should be able to go in and fill in my chart, but if I click this mouse, it's going to take everything away. So I'm going to stop there and write it down, and I want you to go ahead and fill in your chart. Okay, so there's what I have. And I'm hoping that I got them all written down correctly, but I'm fixing to tell you what I had. I had A here, E here, I had G here, I here, C was here, this was K, particle 6, and particle 7 I said was J, 8 was D, 9 was B, 10 was F, and 11 was H. So it looks like we're good on that one. Okay. When I looked at this one, I said, okay, well, let me see what's going on. Looks like I have some parallel plates here, and my particle is attracted in that direction. So I'm going to see if I can figure out which side is which, because that'll help me to know whether I have a positive particle or a negative particle. So I'm going to use the right-hand rule to talk about that. So I said, okay, well, point my thumb in the direction of the motion, and if it is a positively charged particle, then I know that the magnetic field in A would have to be out of the page. If it's a negatively charged particle, then the field would be into the page. So I got to figure out what it is. So hang on a second. All right, so when I read the little prompt that was written up there at the top, it said that when it leaves the region of the magnetic field, it travels between two charged parallel plates and is deflected toward the plate of higher potential. So that means that this plate here is positive, and this plate here is negative. So that means this must be a negatively charged particle, something like an electron. Okay, well, if that is true, then I'm going to take my left hand and I'm going to point my thumb in the direction that the particle is moving. My palm is going to be facing to the right, and my magnetic field here has to be into the page because that's the only way I can experience a force like that. So this is a series of X's. So region A is into the page. Then I'm going to go down here to region B, so you can see that it's going to now be pointing in that direction, the force is. So if that's true and the velocity is still that way, then the field has to be coming out of the page. Okay, I'm going to head straight because there's no field here. I'm going to go to region C, and it's going to be experiencing a force toward the center of the circle like that. And the only way that that's possible if my field would be if my field is coming out of the page. So region C is out of the page. Region D, now I'm headed this way and my force is toward the center of the circle, and here's my velocity vector. So that's only possible if my field is going into the page in region D. Then I have E, a force in that direction. So that's only possible still using my left hand. It's moving this way, so there's my velocity vector. That's only possible in region E if the field is going into the page. And then I'm going to come back here to region F, and it's going to have, let me erase some of this from E, it's going to have forces in that direction while the velocity vector is like that. So the only way that that's possible is if the field is coming out of the page, because my palm needs to be facing to the right. So out of the page is a circle with a dot. All right, and then there's a problem down at the bottom. I didn't work it. You can if you want. I'm not going to mess with it. But hopefully this helped a little bit with the right-hand rule and the left-hand rule. If you're still confused, come by and see me. Please study. Please look at those PowerPoints on my website over page 20, over chapter 20, because I know you're going to find some multiple choice help there.